Everyone, welcome to Practical Astronomy for March. We've moved the date from the third Monday to the second Monday because our presenter for the monthly meeting had to change things around, so that will be next week. We're still, as you no doubt realise, we're staying with our main meetings online. The Young Astronomers group, however, is back at the starting because they have smaller numbers. They're able to go there, and we're hoping before too long we'll be able to resume meetings there as well. It looks like the case numbers in Auckland are starting to come down, so we're just keeping an eye on things at the moment. So this month we're going to look at a review of the autumn night sky. So autumn for astronomy is a little bit different to civil autumn, which just works around for here in the southern hemisphere. We usually say March, April and May are the months of autumn around the calendar. But in astronomy, we divide the year into 4 parts using the equinoxes and solstices. So if you can read the date and time on my screen there, it's showing the 21st of March. So that is the day of the equinox. And if we see the sun there, and the text might be a little bit small for you to read online, but I'll read it out to you. We're seeing the right ascension and declination of the sun on date. It is right ascension 1 minute 55 seconds and declination plus 12 minutes 40.5 seconds at that time of day. And we can see if we actually leave it on the sun, but we'll just wind the clock back. Even though it's gone into the darkness, it's still selected the sun, and we find at 18 minutes past 4 this morning, you notice the declination is still slightly negative, minus 9 seconds of arc, and the right ascension is 23 hours 59, 58:07. And we can just go forward in the minutes to find where the sun goes to a positive declination. So at that instant is where the sun crosses the celestial equator. So it's moved from the southern side of the celestial equator to the north. That point's called the vernal equinox, or the northern hemisphere spring equinox and our autumn equinox. So this is the start of autumn as far as astronomy is concerned. So move back to the night. Well, actually, before I move to the nighttime sky, I'll just show something here. Markings will show the equator of date and the ecliptic of date. And if we move back into the daytime, whoops, click the wrong thing. Okay. And you can see where the ecliptic and the equator cross. The sun is right there. By this time of day today, on the 21st, it's just moved slightly to the northern side of the equator. So that's the marker point for the change of season to autumn for us. Now we'll go to the night sky. Probably about 9 p.m. is okay. It's a bit slow to, that will do. So I'll zoom out to see where we're looking. So this is the view to the north. Now I've selected 9 p.m, but remember that we've still got daylight saving at this point. So we're really an hour earlier as far as the sky's concerned as we will be once daylight saving comes off. And you can see towards the northwest there, we've still got what are considered summer constellations, Orion and Taurus there. And the Castor and Pollux, we'll probably give that as moving into the autumn sky. We've got Procyon, the little dog. So I'm going to move on a bit further to put those summer constellations a bit further to the west. So we'll go forward 1 hour. Okay. So one of the autumn constellations along the line of the ecliptic, if you're not sure what the ecliptic is, that's basically, you can think of it as the path that the sun takes across the sky over the course of the year. It also defines the plane of the Earth's orbit around the sun. The reason it's called ecliptic is because eclipses can only occur when the moon is crossing the ecliptic at some point, and it happens to be lined up either between the Earth and the sun, or with the Earth between the moon and the sun for a lunar eclipse. So that's just sort of like a geometric alignment thing, the reason it gets that name of ecliptic. The blue line you see there, that is the celestial equator, which is defined by the rotation of the Earth. So the axes of the Earth's rotation, the north and south pole, that has an equator, and it's really just the equator of the Earth projected onto the sky. So the two lines are not parallel, and they cross at 2 points, the 2 points being the equinox, the 2 equinoxes that occur each year. And the point where the greatest separation occurs are the positions of the 2 solstices. So you have a winter solstice and summer solstice. If we actually, I'll turn those lines off. Okay. So the first constellation we're going to talk about, which is still on the western side of the sky at 10 p.m. at current time, we've got Castor and Pollux, the twins. The constellation kind of goes up this way. I can probably travelers in stellarium. I'm using stellarium. If I turn art on, it turns it all on. But we can have a quick look at that. Showing with their heads down. That's probably a northern hemisphere centric view. You notice a lot of the constellation art is upside down from our point of view, and that is because it's basically developed for the northern hemisphere. So we'll move on to this little constellation here. We've got Procyon. This is, you've heard of Canis Major, the big dog with the dog star Sirius. This is the little dog. And then above and a little bit further to the west is Canis Major Sirius and the big dog. Moving on a little bit, we can see down in this part of the sky, we have this sickle asterism, and that's often called the sickle of Leo. And again, Leo's upside down for us. Imagine that's his tail, back end, and the head of Leo, and the star Regulus is the considered to be one of the Persian royal stars. And actually, I'll just turn the ecliptic back on. Whoops, wrong one. I want the ecliptic of date. And you'll see that Regulus is very close to the ecliptic. And there are a number of fairly bright stars along the ecliptic that were called the 4 Persian royal stars. I'm going to zoom out a little, zoom in a little bit here. Now, in the area of Leo, I'll turn on deep sky objects because there's a few interesting things here. And as we zoom in, we should see more things appearing. Hopefully that's the way stellarium will work for us. Yeah, here we go. if you're not familiar with these symbols, when you see an oval like that, refers to a galaxy. So the particular triplet of galaxies here is called the Leo triplet. So that consists of the three galaxies. Depending on what your skies are like, Messier 65 is one of them, and 66. The third one, a little harder to see, but the surface brightness is a little bit less. But the other two, 65 and 66, Charles Messier was able to see that in a fairly small telescope back in the 18th century. So the main thing you need for galaxies is a dark sky, because they get obliterated, or most of them get obliterated by the city lights, unfortunately. So that's an interesting object to try and see, even if you can see the two of the brighter galaxies of the triplet. So we'll just wind out a wee bit. Another symbol that's pretty common is the dotted circle that refers to an open cluster. And this constellation here is fairly nondescript, but it's actually Cancer, the crab. If I put the art on, we can see that. And right in the middle of the artwork for the crab there is what's called the Beehive cluster. And this is quite a nice object for small telescopes or binoculars. If we select it, we'll see that it covers a fairly large area of sky, if it will tell us that. Size 1 degree. So in fact, the size of the cluster is greater than the size of the full moon. So this is why it's a good binocular or small telescope object. If you've got a large aperture telescope with a long focal length, you're probably going to have difficulty seeing the whole cluster. We can zoom in to see a stellarium's rendering of roughly what it'll look like. It's quite a reasonable number of stars there. And I guess the name Beehive is because people thought that it looked like a hive of bees, perhaps, with a lot of bees coming and going. Let's zoom out from there. The next constellation I wanted to look at is the constellation of Hydra, the water snake. So if we have a look, not that one actually, must be this one. These are all stars that are in Hydra, but it wasn't the one I was actually wanting to look at. Never mind. This little circlet of stars you can see here is basically the head of the snake, and then the snake's body winds around the sky. And in fact, probably easiest if I show it. Turn on the lines. I'll zoom out so we can see the whole thing. So Hydra is actually the, I'll turn the boundaries on as well for this one. You can, hopefully the red marker shows up there, showing the boundary line of the constellation. Hydra is the largest constellation in the sky. Notice that they cheat with the lines, because the line actually crosses into crater. We'll talk about that in a minute. And then it runs all the way down to the border of Centaurus here and Lupus. So there's a few interesting things about Hydra. If we look, notice that this particular pattern of lines forms this zigzag here. If we zoom in, we can see there's another symbol here that we haven't talked about so far, where you've got a circle. If I blow it up a little bit, which has got little ticks on the outside of the circle at 4 points. That's the symbol for a planetary nebula. So if you're not familiar with a planetary nebula, that's basically a star similar to the Sun that has reached the end of its life, blown off its atmosphere, and leaving the remnant stellar core, which is now in the form of a white dwarf. So when these things are relatively young, they glow quite brightly, and the Ghost of Jupiter is one of these. It's one of the few nebula that you can actually see colour with the unaided eye, because it has quite a high surface brightness still. Over a period of thousands of years, the nebula will gradually enlarge and disperse, and we won't be able to see colour once that happens with the naked eye. Just the telescope view and the eye. Zoom in. I don't know if Stellarium might have a rendering of it. Yeah, it does. If we zoom in a long way, we can see that's not too far from what it looks like. You'll see that turquoisey kind of colour. And the reason they called planetary nebula, I think the term was coined by the Herschels because they were small and round, similar to planets. So that's where the name comes from. But of course, they have nothing to do with planets. They're actually the glowing atmosphere of a star that's died. The glow comes from the ultraviolet light from the hot white dwarf, is causing the gases in the nebula to fluoresce. And I think the the greenish colour is to do with doubly ionised oxygen atoms. Let's zoom out a bit. And we take in the whole of Hydra again. But let's go down to the Hydras tail. And we'll zoom in here. And right on the border of Centaurus is the southern pinwheel. This is one of the favourite galaxies for amateurs, and I think it may be one of the most southern of the Messier objects, Messier 83. So we can go zooming in here. I'm sure it will have a rendering. And it's a great target for astrophotographers, face-on spiral galaxy like that. And we'll zoom back out. And you'll notice there's quite a lot of fainter galaxies throughout this area. But I'm going to zoom out a wee bit. There's another object in Hydra of a sort we haven't talked about before. This time we have a circle with a cross on it, and this refers to another kind of star cluster called a globular cluster. The difference with the other kind of star cluster, which was the dotted circle, the open star clusters. Open star clusters are generally relatively young in astronomical terms, and they have numbers, say, running from the tens to the hundreds of stars, and maybe into the low thousands. But the globulars are much older generally, and they're also far richer, as you can see in this rendering. There's a lot of stars that are all blurred in together that are unresolved in this rendering. Some of the globulars can have upwards of 1 million stars in them, and we'll come across a couple like that later on. Meanwhile, I'm going to zoom back out, and there's a couple of other constellations. We have here the constellation Crater, the Cup, and this is said to be looks a bit lopsided in the picture there, but we can put the artwork back on. And we see the cup again for us, southern hemisphere ourselves upside down. Interesting, the one next to it there's could be the right way up, or a bird flying upwards anyway. That's the constellation Corvus the Crow. I'll talk about that a little bit more in a minute. Turn those off. In mythology, the water snake, the cup, and the constellation of the Crow here are related by a story about Apollo, who sends the crow to fetch water, and the crow gets distracted and ends up claiming that he was disturbed by a water snake, and Apollo doesn't buy the story and flings the water snake and the crow into the sky. So that's apparently the source of the names of these objects. Down below the crow, if we have a look here, you'll see there's another popular galaxy with amateurs, Messier 104, the Sombrero galaxy. And this one is actually can punch through a bit of light pollution because it has for a galaxy, it has a reasonably high surface brightness. You'll only see it as a sort of a streak of light, but worth hunting down. If you don't have a go-to telescope, you can use the Corvus. I think I first learned this scheme off Andrew Buckingham probably 20 years ago. But what you do is you start on this end of the crow. If you see the sort of the sort of squashed quadrilateral shape, and with this brightish star off the end, you know you're heading the right way. And in your finder or binoculars, you should be able to readily find these three stars in a row with one slightly off center. And you can use that as a pointer. They're 6 magnitude, something of that, or 6.7, 6.6. So they're easy to see in binoculars or finder. And you just follow the direction of that arrow, if you like. And then you see a fainter triplet of stars here, but they're still visible in binoculars or finder. And they basically point to the location of Sombrero. So that's a nice little star hopping trick you can learn if you're wanting to find the Sombrero galaxy. So let's zoom out. If we go, these constellations here are more towards the top of the sky. So I won't talk about those at the moment, but before we swing over to the southern side, what I'm going to do is move on a couple of hours, where we're still in the autumn, but let's go an hour, 2 hours. So we're probably looking at the sky now as towards the end of autumn. Now, if you're not familiar with it, each day the stars rise 3 minutes and 56 seconds earlier, and over the course of a month it's roughly 2 hours earlier. So as the year goes on, new stars come into view rising in the east, and obviously over the course of the year, 12 times 2 is 24, you're back to where you started again. So we're basically seeing some new constellations starting to appear. So we've got this, it's got a bit of a funny stick symbol. This one here is called Coma Berenices, and it's a little bit north for us, but Coma Berenices basically means Berenices here, because there's a lot of faint stars in there, and I guess from a really dark sky, you might think that there's sort of trails of here, perhaps, but that's where that comes from. Now, above Coma Berenices, we've got this large constellation here, which is the constellation Virgo. In fact, what I didn't actually mention before is that the Sombrero galaxy up here is actually really officially in Virgo. It's just across the border of Corvus the Crow. Now, Virgo, I don't know if you've heard of it, but the constellation Virgo contains the Virgo galaxy cluster. In fact, our own galaxy is sort of the local group of galaxies is an outlier of the Virgo cluster. And if we start to zoom in, we'll see many more galaxies. And I think this line up here is called Macarian's chain, a chain of galaxies. Some other, quite a lot of Messier objects in here, as you see. Some of them got quite fanciful names, the Silver Street Galaxy. You generally need a dark sky to see them. The Eye is an interesting name. And this one here, Messier 87, is a giant elliptical galaxy in Virgo, and it's I think it's believed to have a black hole in it that's ultra, something like, instead of millions of times the mass of the sun, it's up to 1 billion times. So it's a really large black hole in there. It's known to have, in photographs, it's possible, in fact, I might show it in this rendering, that it's got jets coming out of it. The galaxy isn't hard to see because it is quite bright as long as you get away from the light pollution. But you'll just see it as a fuzzy blob. You won't be able to resolve any stars just at the eyepiece. But you'll see it has a number of neighbouring galaxies. There's a nice sort of lenticular type galaxy there, Messier 90. Or a type of spiral, maybe. Anyway, if you've got a decent aperture and a dark sky location, it's definitely a place to go for galaxy hunting and for astrophotographers as well. So let's zoom out a bit from there. And down here, it's really a northern constellation, is the constellation of Bootes, the herdsman. But this star here is really prominent in the sky. It's one of the brightest stars. It's brighter than first magnitude. If you can see the, does it tell us the visual magnitude here? Magnitude 0.15, so it's one of the brightest stars in the sky. And it's a reddish star, and the interesting thing is that because it doesn't get real high in the sky, it's often affected by scintillation, and people apparently stardom get reports of, oh, there's something funny flashing in the sky to the north, and quite often people are seeing Arcturus. Now, if you're wondering what this really bright thing here is, that's actually the moon. So the moon is also contributes to light pollution, especially as it's waning towards full, as it is at the moment. In fact, does it tell us, this is next week, so does it tell us what the phase is somewhere? Well, 87% illuminated, so we've got a really bright moon there. And the last constellation I'm going to talk about is for this part of the sky, and basically the, I guess we'll just arbitrarily say it's the end of the autumn sky. If you want to stay up much later, then you can see all of the other things coming up. But these are the ones that are more conveniently located. But this one here is called Libra, the scales. And well, there's not a lot of interesting deep sky objects in Libra, but it's got two stars that are some people's favourite star names. We have Zubin-el Janubi, and down here Zubin-Eshamali. And originally these two stars were actually part of the Scorpion. Notice Scorpius just sneaking in over here. And they were the southern claw and the northern claw respectively. But at some stage, this piece of sky got cut off from the Scorpion and made into Libra. Okay, at that point, I think we'll leave the northern sky and switch around to the south. But before I do that, I will go back to a earlier time. Oops, oh, that'll do. Just before 10, that will do it. So let's now drag the screen around. So we're pointing south. Okay, so I'll get rid of the constellation boundaries actually, because it's looking a wee bit cluttered there. Turn those off, and we'll turn off the lines. Okay, that's a bit better. So from this point here, we're looking due south, and okay, I cheat because I've got stellarium telling me where south is. But if you're not familiar with how to find south, we can use a couple of things here. If you see these two bright stars, this is our neighbouring star system, the Alpha Centauri system, Alpha Centauri A and B. There's also a third member called Proxima Centauri, which is a little bit displaced by a degree or so. Because the system is 4 light years away, and the Proxima is considered to be part of the system, even though it looks fairly widely separated on the sky. But it appears that the shares what's called proper motion. In other words, over a long period of time, these stars, Proxima and the binary system, Alpha and Beta Centauri, sort of drifting through the galaxy together. So anyway, we come up here to Beta Centauri, also known as Hydra. By the way, these, we tend to say Alpha Centauri, and that's the most commonly used name, but navigators called it Rigel Centaurus, as it's one of the navigation stars. And that name seems to have been picked up by the IAU, so that is now an official star name. So, but I'll continue saying Alpha Centauri, I think. Anyway, we follow the line of these two stars and we find the Southern Cross. So the brightest star in the cross, Alpha Crucis or A Crux. And then on the other end of the cross, GA Crux. And then we have Beta Crucis, or whoops, didn't select that well. Sometimes stellarium does this when it thinks there's a more interesting object. There we go. Mimosa is Beta Crucis, and then Delta Crucis. And you'll see there's this, the Australian flag actually shows this star, Eta Crucis. Don't know why we don't have it on the New Zealand flag, but anyway, I've got a bit sidetracked here, but we use the pointers and the Southern Cross. If we draw a line down the long axis of the cross, and then we draw another line bisecting Alpha and Beta Centauri, the South Celestial Pole is more or less or not too far off where those meet. Another way to do it, you can use the long axis of the cross down to the star Achernar, which is Alpha Eridanus, and the midpoint of that line is again roughly the southern celestial pole. So to check that, we can turn on the equatorial grid, and that's the exact position. So you find that when you draw it, it's not exact, but it gets you in close into the region of the south celestial pole. If you're wanting to actually align your mount, you have to be a lot more accurate. But there's another scheme. I've zoomed in a bit here. What you can do is follow the line from Achernar towards the Small Magellanic Cloud, if you can see it. I'll talk about a little bit about that. But this star, brightest star here is Beta Hydrae, is third, but bright, a bit fainter than third magnitude. But if you follow this line past the Magellanic Cloud, and then you find these sort of stars here. Again, I remember I had that scheme for finding the sombrero. You've got 3 stars where you can use the middle star not being quite in a line as a pointer. So we carry on from Beta Hydrae through these 3 stars, and we notice this asterism of 4 stars, again a quadrilateral that's slightly bent out of shape, and this star here is Sigma Octantus, or Polaris Australis. So if we put the grid back on, we can see that it's still not exactly on the pole, but it's a good first starting point for aligning an equatorial mount. Probably good enough for visual use of an equatorial mount, but if you were doing photography, unfortunately, it's still not close enough. You can use a polar alignment scope, and if you're lucky enough to be able to see these stars in the reticle will have markers for them if it's marked out for the southern hemisphere, and will show you the pole. You can also use some of these camera-based schemes where you get the mount roughly pointing in the direction of the pole, and then you photograph it, and the software will tell you what the error is, and you adjust your altitude and azimuth appropriately. Astrophotographers no doubt go through the pain of doing that with an equatorial mount. Unfortunately, I didn't mention it, but these stars are really hard to see. Really difficult from a suburban sky. As you see, we're talking, the star is only just a bit brighter than 6 magnitude. But interesting things to see, particularly the Small Magellanic Cloud, which is from a country site with no moon, and even from the outer suburbs of Auckland, you can see this still. We haven't quite wiped it out with light pollution yet. Centre of city, not a chance, or even inner suburbs. These 2, it's not actually selecting it, but this is the large Magellanic Cloud and the Small Magellanic Cloud. They are dwarf galaxies that are orbiting the Milky Way, and they are being affected by the Milky Way as well, and they leave tidal streams across the sky that I believe both from tidal interaction with the Milky Way, but also there's some interaction with each other apparently. So if we zoom into the small cloud, we've got a couple of interesting objects here. We've got 47 Tucanae, which is, I'll just lock it in. This is the second brightest globular cluster in the sky. If we zoom in, it's an incredibly rich globular cluster, which is really concentrated towards the centre, and definitely worth looking at in any kind of telescope. Even it's quite easy to see in binoculars. You won't resolve the stars in binoculars. You'll see it as a fuzzy blob, but still quite easy to see. Now, you'd think, oh, there's the Small Magellanic Cloud. There's a lot of open clusters and other things in the nebula, and those are actually physically associated with the Small Cloud of Magellan, as it's called. 47 Tucanae is absolutely nothing to do with the Small Magellanic Cloud. It's pure chance alignment. The large cloud is something like 200,000 light years. The small cloud, I should say, something like 200,000 light years distance, whereas 47 Tucanae is much closer. I don't know if this is telling us distance, estimated distance. Oh yeah, says 15,000 light years roughly. Not sure of the accuracy of that. Some of these tend to have fairly large error bars, but obviously a lot closer than the dwarf galaxy in the background. Often overlooked, this object here, caldwell 104 NGC 362, is another nice globular cluster. People tend to go for 47 Tuc, but because it is brighter and a lot richer, but this is quite a nice globular in its own right. If you happen to be in this part of the sky, it's definitely worth trying to find that. And to find it, it's not too hard if you if you know the position of the Small Magellanic Cloud, and you know where you found 47 Tucanae off this end, then sort of stay on the same side of the small cloud, but drift towards the other end. You should be able to find it fairly readily. Okay, I'm going to zoom out. Oh, I didn't say which constellation this is in, except it's sort of given away by the name 47 Tucanae. It's the toucan, and if we bring up the art for that, you can see, again, we get an upside down toucan. How unfortunate. Okay. Over here, sort of lower down in the sky, is the constellation of Parvo, the peacock. And here we've had quite another nice globular cluster, a bit low in the sky. It's only just coming up at this time, but as we get further into the autumn, it'll be in a more convenient location. And you see this is quite a bright globular, 6 magnitude. The star here is part of the constellation of Triangulum Australis, or the Southern Triangle. So we can see these stars there. We had the peacock. Whoops, I'll just cancel that. Let's we've got a galaxy, fairly faintish galaxy in here, Caldwell 101. So the Caldwell catalogue, where you'll see this with some objects starting with C, are basically that Patrick Caldwell Moore. Caldwell was his middle name, or his mother's maiden name, or something like that. I might be wrong there, but you can look it up. Anyway, he decided to extend the Messier catalogue to include objects that should have been in it. Plus, a lot of them are in the southern sky because they weren't visible to Charles Messier at the latitude of Paris. He couldn't see a lot of these southern objects. So we can see the Parvo, the peacock. and it covers quite a large area of sky as well. And these southern constellations, they are given names that are either creatures that were new to the Dutch navigators that first came to the southern hemisphere. They were the first Europeans to see the southern sky. Of course, the indigenous people in Australia and New Zealand were well aware of it. But a lot of the names that found their way into the IAU catalogue came from basically the Dutch explorers. I'll turn this artwork off. We're going to go up. Oh, actually, I should leave it on again. If we turn that on, and also the equatorial grid, you can kind of see how it overlays. I didn't mention, but Sigma Octantus, again, this is one of the modern constellations as far as its name goes, referring to a navigational instrument, the octant. Okay, let's come up to the Large Magellanic Cloud. The large cloud is a little bit closer to the Milky Way than the small cloud. It's, I believe, something in the order of 170,000 light years. There's an interesting thing here. Back in 1987, there was the first supernova spotted that year. 1987A was actually in the Large Magellanic Cloud. It was co-discovered by variable star observer down in Nelson, Albert Jones, the late Albert Jones now. And you've probably seen some of the Hubble Space Telescope photographs of the aftermath, which has left rings of gas illuminated as the supernova remnant has actually expanded into the galaxy. So in the Milky Way itself, we haven't observed any supernova since 1604, named after Johannes Kepler, the Kepler supernova, and it's really named after him because he did a lot of observations and recording of its brightness and how it changed over time. So it got named in his honour because he was probably the prominent observer of it. For astrophotographers and also visual observers, there's a lot of interesting stuff to see in the large cloud. There's a lot of nebulosity if you can get to a dark sky. The most famous one is this area here called the Tarantula Nebula because of it having a spiderish look to it. So right in the middle of the Tarantula Nebula, there's a star cluster, I think it's called R136, and it was believed to be a single star called S Doradus, but it's now resolved as a multiple star system, and it contains large numbers of really massive hot stars, and in particular R136A, which is sort of the central part of the cluster, has some incredible stars, one of them believed to have a mass of 200 times the mass of the sun, and all of these stars are basically flooding this nebula area, which is glowing from the ultraviolet radiation being put out by these really hot young stars. So definitely a part of the sky of interest to amateurs, either photographically or for visual observing. So we notice that the rest of the southern sky around the pole is fairly faint, but we can see over this side, we're seeing the Milky Way. And of course, the Southern Cross. I will go back to it because there's a few things we can talk about here. As the jewel box cluster, or Kappa Crucis, also NGC 4755. So this is a really easy one to find because you can find the Southern Cross. Look for the second brightest star, Mimosa, and you'll easily find it. And you'll find the cluster's actually visible, and binoculars will find it, although it'll be not that well resolved, but it's pretty obvious. And then you can get the telescopic view of it. Going up the Milky Way, these are sort of a really rich part of the sky. We have the Pearl cluster, the famous Wishing Well cluster. This is again another cluster that's great for a small telescope, and a large aperture long focal length you will only see the central part of the cluster here. I should mention this, I talked about the ghost of Jupiter before. This is quite small, but it's also a planetary nebula that you can see colour in. And the way to find this one is to use the Southern Cross again. You use the short axis, go roughly as far to this part of the sky here. Let's zoom in a bit. You can see, and it's quite obvious in a finder scope, you'll see these four, again, a quadrilateral that's been squashed out of shape, if you like. And you can see these four stars fairly easily in your finder. You won't see the blue planetary because it's a bit too faint for your finder, unless you've got good eyesight in a really dark sky. But if you position your field so that you're between these two stars, or maybe about a third of the way from this end, you should be able to find it. And it's very small, even at say 100 magnification, so you probably want to bump the magnification up. And because it's quite high surface brightness, you can crank up the magnification quite a bit on this one. However, we haven't finished with this part of the sky yet. Coming into view over the autumn, we go back to our pointers, and instead of following the line to the Southern Cross, we hang a left, and you'll see this star fairly easily, Eta Centaurus, and you carry on about the same distance, and we find here the Omega Centauri cluster. This is the biggest and brightest globular cluster in the sky, although modern theory says that it's not really a globular cluster at all, that it's possibly the remnant core of a small galaxy that was absorbed by the Milky Way. And the reason they think that is because generally globular clusters are old populations of stars, but this star appears to just have three distinct populations. So it was formed from more than one star forming episode, which you don't really see in the other globulars, so that's the reason. So that's the Omega Centauri cluster. This is, I'm sure people in the Northern Hemisphere would really are jealous of us having this one as a Southern Hemisphere object. It, in a really large aperture scope, where you're starting to resolve a lot of the stars, it just looks like the whole field of view is full of stars that sort of look like grains of sand scattered over the field of view. Really, if you haven't seen it, it's a must to look for. So we carry on actually on the same line roughly. And again, you need a fairly dark sky to see this. I can just barely see this at home. Even at the observatory with the 20-inch Zeiss telescope, I cannot see this through the eyepiece. It's just because of the light pollution. Years ago, it would have been quite easy. If you're at a dark sky site, this galaxy Centaurus A is quite easy from a small telescope. And I've zoomed in there and you can see the dark dust lane. A society member, Rolf Olsen, had done a really deep image of this galaxy, maybe 100 hours of imaging in different filters. And it's a rather famous image taken by a member of the society, not the one shown here, but I'm sure if you look it up on the internet, you'll find Rolf's image of the Centaurus A galaxy. So let's zoom out. We'll actually just go forward in time a bit. So we'll go to something like midnight. And we're starting to see some of the beginning of some of the winter's objects coming into view. I don't know that I should cover those now. Maybe just some of the things that are a bit higher in the sky. Stellarium's doing something funny with its rendering here. I won't talk about the Scorpius because that's really getting into the winter objects. What could we look at that's, oh, I know. Yeah, we should talk about a couple of other southern objects that were sort of in the sky before, but we'll zoom out a bit again. And we'll come back to the Southern Cross. We didn't need to go forward in time for these. Sorry about that. I decided that doing that was getting too much into the winter sky. So what I wanted to talk about here was this little, again, roughly a quadrilateral that's been slightly squished out of shape from a rectangle. This is the constellation of Musca, the Fly. So if you I'll actually turn the art back on so you can see the fly there. Oh, and the big horse-looking thing is the centaur, Centaurus. I didn't turn on the artwork for Centaurus. Anyway, zooming into, if this is quite worth having a look, there's a couple of globular clusters in here. This one here is actually not hard to see, caldwell 105, and you can find this by star hopping. If you can see the main bright stars of Musca, you can go down to the end that's got the wider separation. So you sort of make your way down here, probably a quarter of the way coming from this end going back towards there. You should be able to see this globular. It's not too bad. It's a bit fainter than some of the others we've looked at. And this one here, this is a little bit more of a challenge, but is worth looking for if you've got a dark sky site. This here is really a photographic thing called the Dark Doodad Nebula. There's actually a dark lane in the Milky Way. So there's some interesting photographs of the Dark Doodad Nebula shown against the background stars of the Milky Way. It's not really a visual object. I'm going to zoom out a bit. There was one other thing I was going to talk about before we finish. Oh yeah, that's right. I just remembered what I was going to mention. So let's put the artwork back on here. And this is right next to the constellation Musker the fly. And yeah, if we look at the large Magellanic Cloud here and Musker and the Southern Cross over this way, the constellation roughly in the middle here is called the Chameleon. And if we zoom in on it a bit, there's a kind of asterism that makes a little bit like, if you're familiar with the Big Dipper in the Northern Hemisphere, this is sort of similar to a Little Dipper, maybe, depending on how you view things. You've got the head of the chameleon at this end, and then down to his tail. And of course, the chameleon is well known to be hunting the fly. So the Musker there needs to be on the lookout. Probably it's 9 o'clock, so we better leave it there. I'll just put the artwork on so we can see that. Actually, for that purpose, the chameleon is really facing the wrong way if he's trying to catch the fly. But anyway, over to Steve if we've got any questions from the YouTube chat.
Thanks, Bill. No questions as such, but I did ask the audience if they had any favourite objects that maybe you'd not shown. And Craig suggested the Pencil Nebula. He said that's something different.
Oh, okay. I'm not familiar with that name. Let's see. Have you got an NGC number for it? I'll just try see if Stellarium knows it. Let's have a go. Oh yeah, it looks like it does know it. Oh, okay. So this one is in Argo Navis or in Vela by the look of it. Hang on, I better get rid of the art. Oh, okay. I've only ever seen photographs of this one. I didn't mention this part of the Milky Way has got quite a lot of nebula in it. The most famous one back here being Eta Carinae, the great southern nebula, I suppose you could call it. But yeah, this pencil one is quite intriguing. I don't believe I've ever seen it visually. Did they say whether it must be visually seen because it's a caldwell object, but it probably requires quite a dark sky, so it's something that I must have on my to-do list, I think.
Yeah, I just did a look up on Sky Safari. As you know, I've never got Sky Safari too far away. It's also known as Herschel's Ray and is part of the Vela supernova remnant.
Right, okay, yeah. It is that picture of the artwork got it right as far as which constellation it's in. It is in Vela. Okay, interesting.
There's no more questions.
Okay, well, thanks for that. Hopefully everyone will be able to tune in next week, and we'll keep everyone posted when it's going to be possible to return to the Stardome. When we do that, we will continue to live stream on YouTube when we can. We can't live stream all meetings, like obviously a planetarium session, which this would normally be. We can't do on live stream, so you have to be there to see that one. But our other presentation type ones, we will be continuing to live stream once we're back at the Stardome. Okay, thanks, Steve.
Thanks, Bill.